Imagine the end of everything. What will it look like when the universe takes its final bow? Will it be a gradual fading of all stars, a dramatic cosmic crash, or an instantaneous annihilation? For decades, astronomers believed they had the answer, a slow heat death, but new discoveries suggest the cosmos might have a few twists in store. Today, we'll explore 5 possible ways the universe could end, ranked by scientific likelihood. From the most accepted theory to a couple of wild cards, let's travel trillions of years into the future and beyond, to witness the fate of reality itself. The Big Freeze, also known as heat death, is the reigning champion of cosmic end scenarios. This fate is basically the universe quietly going to sleep. Trillions of years from now, all stars have exhausted their fuel. Galaxies, including our Milky Way, stop forming new stars and go dark. The expansion of the universe keeps stretching everything farther apart. Over unimaginable timescales, even black holes evaporate away. What's left is an ever-expanding, near-empty void at a uniform, cold temperature. In this final state, nothing new can happen. No energy gradients, no light, no life. It's called heat death, not because it's hot, but because all useful heat, energy, is evenly spread out as low-level background warmth. Essentially, the cosmos becomes an eternal dark calm, where entropy, disorder, is at its maximum and no structures remain. Why do scientists consider this the most plausible outcome? All current observations point that way. Distant galaxies show the universe is expanding and even accelerating, driven by mysterious dark energy. If dark energy is a constant property of space, as most evidence suggests, this expansion will continue forever. Gravity won't pull everything back together. Instead, galaxies get more isolated. Eventually, each island of matter uses up its resources and fades. This slow fade-out is a very gradual process. Stars will shine for billions or trillions of years. So if heat death is our fate, the universe has a long, quiet old age ahead of it. It's a rather melancholic ending, an eternity of nothing happening. But from what we know so far, it's the frontrunner. Coming in at number 2 is a more violent and faster doom, the Big Rip. This scenario is like the universe dying in a spectacular cosmic explosion, except the explosion is the fabric of space itself tearing apart. How does that happen? It all hinges on dark energy and how it behaves. If dark energy isn't content to remain constant and instead gets stronger over time, a possibility in some theories, the expansion of the universe would speed up more and more. In a Big Rip scenario, this repulsive force of expansion grows so powerful that it ultimately overcomes all other forces: gravity, electromagnetism, you name it. Imagine a time in the distant future when galaxies are receding at mind-boggling speeds. First, galaxies would be torn from each other's gravitational grasp. Next, the stars in each galaxy get pried apart from their galactic core. Then, planetary systems, planets, and eventually molecules and atoms themselves are ripped to shreds. In the final moments before the rip, even the fabric of space-time is stretched to the breaking point. The universe ends as an infinitely expanding, shredded mist of fundamental particles. Essentially, everything gets stretched into oblivion. It's a dramatic end worthy of a sci-fi movie. Every atom, every galaxy, and even space-time ripped apart. But is it likely? Based on current data, the Big Rip seems less probable than heat death. Our measurements of dark energy so far fit best with a constant force, the cosmological constant. However, we can't be entirely sure. If dark energy turned out to be a more exotic phantom energy that intensifies, a Big Rip could happen. Some cosmologists have calculated that if the Big Rip were to occur, it might be roughly 22 billion years from now, not very soon in human terms, but noticeably earlier than heat death's trillions upon trillions of years. The good news is that so far, observations don't show dark energy growing unbounded, so we likely don't need to worry about the universe tearing itself apart out of the blue. It remains a hypothetical doomsday, eye-opening, but on the fringe of current plausibility. Now for a truly mind-bending possibility, vacuum decay, sometimes nicknamed the Big Slurp. This is a quantum twist on how the universe could end, and unlike the previous scenarios, it wouldn't unfold slowly or even be driven by cosmic expansion. It could strike at any time without warning. Vacuum decay comes from the realization that what we call empty space, the vacuum, might not be completely stable. In our current universe, the vacuum has a certain energy state determined by the Higgs field, the field associated with the Higgs boson particle. Some physicists suspect that the Higgs field, and thus our vacuum, is in a metastable state. That's like a ball resting in a shallow dent on a hillside rather than the absolute lowest point in the valley. It's stable for now, but given a big enough jolt, or a random quantum fluctuation, the ball could roll into a deeper low point. If our vacuum finds a deeper state, physics as we know it changes dramatically. Vacuum decay means a tiny region of space spontaneously tunnels into a true vacuum state, the lower energy state. This bubble of true vacuum would then expand at nearly the speed of light in all directions. Everything it touches would be fundamentally restructured. Atoms, forces, and the very laws of physics inside that bubble could be different. To any observer, not that there could be any, it would look like the universe is being instantly erased by an ever-growing bubble of nothingness. Within that bubble, matter as we know it wouldn't remain. It's essentially a cosmic factory reset. In a sense, the universe would slurp itself up, hence the ominous nickname Big Slurp. It's hard to imagine a more complete apocalypse than vacuum decay. One moment you're there, the next, a wall of true vacuum sweeps over you at light speed, and poof, you and everything else are gone with no warning. The scariest part? It's actually allowed by known physics. In fact, given the measured mass of the Higgs boson, our best models do imply the vacuum is likely metastable. The good news is that if vacuum decay is possible, it seems extremely unlikely to occur anytime soon. Physicists have estimated the spontaneous decay of our vacuum is so rare that the expected time for it to happen is astronomically huge. Numbers like 10 to the power of 100 years are thrown around. That's a 1 with 100 zeros years, far, far longer than the current age of the universe. In other words, don't lose sleep over this one. It's the ultimate long-shot end. However, it's not entirely implausible in principle. This concept keeps scientists awake for a different reason. It's a clue that our current understanding of physics is incomplete. It motivates new physics research and colossal particle colliders to better pin down if we are in a false vacuum or a true one. If we're lucky, maybe our vacuum is truly stable, and this scenario can be laid to rest. But until we know for sure, vacuum decay remains a fascinating, if eerie, wildcard, a reminder that even nothing, empty space, might hide the seeds of our destruction. Now let's consider a sort of reverse of the Big Bang ending, the Big Crunch. This scenario is basically the universe's expansion slamming into reverse. Instead of spreading out forever, at some point the expansion would slow, stop, and then everything would start rushing back together. Galaxies would begin to draw closer rather than recede. Over billions of years, all matter and space itself would collapse inward, getting denser and hotter. Eventually, the entire universe would crunch into an extremely hot, dense state, perhaps all the way back into a single point, a singularity, essentially the Big Bang in rewind. In a big crunch, galactic collisions become the norm. In fact, long before the final collapse, Our own Milky Way galaxy might merge with others as everything contracts. As the universe shrinks, the night sky could grow crowded again with galaxies. Temperatures everywhere would rise as density increases. In the final moments, stars might ignite or merge, and black holes could devour swaths of matter as gravity overwhelms all. Finally, all distances shrink to zero, and the universe as we know it implodes, possibly ending as an infinitely dense point or triggering a new Big Bang. More on that soon. The Big Crunch was once a serious contender. Decades ago, many scientists thought gravity might eventually halt the expansion and pull everything back. But the discovery of accelerated expansion, dark energy, in the 1990s drastically dimmed the prospects of a crunch. With the universe flying apart faster and faster, a collapse seemed off the table. So, is the Big Crunch completely dead? Not necessarily. It's considered much less likely under current data, but there's a caveat. What if dark energy changes over time? If dark energy were to weaken, or even become attractive instead of repulsive in the far future, cosmic acceleration could slow down. In an extreme case, it might stop and flip to deceleration. Recent findings have indeed hinted that dark energy might be dynamical rather than perfectly constant. These hints are very preliminary, but they crack open the door, just a little, for a Big Crunch possibility eons from now. In summary, Big Crunch is currently a long shot. The universe's shape appears flat, and its energy content, with dark energy dominant, points to endless expansion. To actually recollapse, we'd need some dramatic reversal in the cosmic balance, something we don't have evidence for at the moment. Still, science is about remaining open-minded. If tomorrow we discovered dark energy fading away, the Big Crunch could move up in plausibility. For now, we rank it as a remote but theoretically possible fate. It's a captivating idea, the universe ending not in ice or fire, but in a furious collapse into itself, perhaps to be followed by something new? Our final scenario is a bit of a cosmic phoenix. The universe dies, but then is reborn in a new cycle. This is often called the Big Bounce theory. In a Big Bounce model, the end of our universe would also be the beginning of the next one, in an eternal series of universes. How might this work? There are a couple of variations. One involves a Big Crunch leading directly into a new Big Bang. The universe collapses completely, and then bounces outward again. Another variation, inspired by an idea from Nobel laureate Roger Penrose, suggests that even a heat-death end state could, in the very far future, effectively trigger a new Big Bang, starting the cycle anew. In Penrose's conformal cyclic cosmology, our endlessly expanding, empty universe would eventually become so featureless that, in a strange twist of physics, it can be reinterpreted as the extremely hot, dense state that births a new universe. In other words, the silence after heat death might secretly loop back to the fire of a new Big Bang. Mind-bending, right? No matter the flavor, all Big Bounce ideas share the notion that our universe isn't the first or the last. Universes come and go in cycles. If the universe undergoes a Big Crunch, as in scenario number 4, that crunch might be the next Big Bang. Alternatively, if the universe drifts into a heat death, scenario number 1, after an incomprehensible length of time, it could forget its scale and spontaneously reset into a new bang. Some speculative quantum gravity models also hint that the Big Bang could have been a bounce from a previous collapsed universe, avoiding the need for a true beginning of time. Now, how plausible is the Big Bounce? At this point, it's highly speculative. There's no direct evidence that a bouncing cycle is real. Observational cosmology, like the cosmic microwave background, hasn't revealed definitive imprints of a previous universe. Though a few researchers have claimed there are hints, those claims are debated. The bounce idea is attractive because it could potentially solve the puzzle of what caused the Big Bang. It was just the end of something before. But until we have a testable mechanism or evidence, the big bounce remains on the fringe. Most mainstream cosmologists consider it an intriguing but unproven idea. It's essentially a way to dodge a true end by saying the end is just a new beginning. That said, it's a hopeful thought. Even if our universe dies in a crunch or heat death, maybe cosmos as a whole isn't done. It gets reincarnated. Science hasn't confirmed this cycle, but it's a comforting concept to ponder when contemplating ultimate doom. The Big Bounce stands as a speculative finale, one where the end might just roll the credits and then start the next episode of existence. As we've seen, the end of the universe could play out in various ways: slow and cold, violent and quick, or perhaps not an end at all. The Big Freeze is the frontrunner according to current science, promising a quiet demise in darkness. Yet, the door to more dramatic finales, like the Big Rip or Big Crunch, isn't entirely closed. New data could tilt the odds. And then there are those exotic wildcards, like vacuum decay's sudden strike, or the eternal rebirth of a big bounce, reminding us how much we still don't fully understand. So, as we conclude our journey to the end of time, take a moment to appreciate the cosmos we live in now. It's dynamic and alive with stars and galaxies, a far cry from some of the desolate endings we discussed. The universe's story is still unfolding, and we are lucky participants in its mid-act. The final chapter? Yet to be written. And who knows, perhaps in the far future, intelligent life, maybe our distant descendants, will puzzle over how the next universe will end. The cosmic story goes on, and for now, so do we. Thanks for watching. If you enjoyed voyaging across eons and pondering cosmic finales, hit the like button and subscribe for more journeys through space and time. And let us know in the comments, which end-of-universe scenario fascinates or terrifies you the most? Until next time, remember, the universe may someday end, but curiosity is eternal.